You think the speed of light is just fast? 300,000 kilometers per second. The fastest thing we know. But why can't you go faster? Most people say, well, that's just the law. That's the cosmic speed limit. You can't exceed it. But that's not an answer. That's just repeating words. When you really ask why nothing can go faster than light, when you dig into what's actually preventing you from accelerating past that speed, when you work through the mathematics and follow the logic to its conclusion, you discover something so profound, so fundamentally strange about the nature of mass, energy, space, and time that it changes everything you think you know about motion, about physics, about reality itself. The speed of light isn't just a speed limit imposed on the universe. It's built into the fabric of space-time. It's a consequence of how space and time are woven together. And the reason you can't exceed it isn't because you run out of fuel or because your engine isn't strong enough. It's because the faster you go, the more you resist acceleration. Your mass, in a sense, and as you approach the speed of light, your mass approaches infinity. To actually reach the speed of light would require infinite energy. Let me show you how I figured this out, and why it reveals something deep about the structure of space-time itself. Newton's second law. Force equals mass times acceleration. You apply a force, the object speeds up. Apply more force, it speeds up more. This works for everything in everyday experience. More force, more acceleration. Apply enough force for long enough, and you can make something go arbitrarily fast. That's what Newton believed. That's what everyone believed for 200 years. And the problem had to do with light. In the 19th century, James Clerk Maxwell developed a complete mathematical theory of electricity and magnetism. Maxwell's equations showed that light is an electromagnetic wave, and they predicted the speed of light. The speed falls right out of the equations, about 300,000 kilometers per second. This was remarkable. But here's what bothered me as a young man. Maxwell's equations don't have any reference to a frame of reference. They don't say the speed of light relative to what. They just give a number. 300,000 kilometers per second. In Newtonian physics, if you're on a train moving at 50 kilometers per hour and you walk forward at 5 kilometers per hour, you're moving at 55 kilometers per hour relative to the ground. But what about light? If you're on a train moving at 100,000 kilometers per second and you shine a flashlight forward, how fast is the light moving? Common sense says it should be the speed of light plus the speed of the train. But Maxwell's equations don't say that. They just say light travels at 300,000 kilometers per second. The equations don't care if you're moving. Michelson and Morley did the experiment in 1887. They measured the speed of light in different directions as Earth moves through space. Light traveled at the same speed in all directions regardless of Earth's motion. I thought about this for years while working at the patent office. What if the speed of light really is the same for everyone, no matter how fast they're moving? What if that's a law of nature? Light always travels at 300,000 kilometers per second relative to you. This seems impossible. It violates common sense. Let's take this seriously. Let's assume the speed of light is constant for all observers and see what follows. What I found was that time and space cannot be absolute. Flex, change depending on your motion to keep the speed of light constant. This was special relativity published in 1905. Here's what happens when you try to reach light speed. Let's imagine you're in a spaceship. 10% the speed of light, 50%, 90%, you keep firing your engines. But the faster you go, the less your velocity increases for a given amount of thrust. It becomes harder and harder to go faster. Why? Because your inertia increases. The faster you go, the more you resist further acceleration. It's as if your mass is increasing. We call this relativistic mass. The formula is m equals m anifolb, divided by the square root of 1 minus v squared divided by c squared, where m anifolb as your rest mass, c is the speed of light. and m is your relativistic mass at velocity v. When v is small compared to c, your mass is approximately your rest mass, but as v gets closer to c, the denominator approaches zero, so mf approaches infinity. Your mass, your inertia, grows without bound. At 87% the speed of light, your mass is about twice your rest mass. You're twice as hard to accelerate. 5% the speed of light, your mass is 10 times your rest mass. 995% the speed of light, your mass is 100 times your rest mass. As you approach the speed of light, your mass grows without limit. To accelerate you further requires more and more force for less and less change in velocity. To actually reach the speed of light would require infinite energy. You'd need to accelerate an infinite mass. No finite amount of energy can do this. So you can never reach the speed of light. You can get arbitrarily close. 99.9%, 99.99999%, as close as you want there. The speed of light is an asymptote. You approach it, but never reach it. This isn't because of engineering limitations. It's that the universe itself prevents it. The structure of space-time is such that massive objects cannot travel at a speed. This is a law of nature, as fundamental as the conservation of energy. But light itself travels at the speed of light. How? The answer is that photons have zero rest mass. Massa I equals zero. Massless particles must travel at the speed of light. They cannot travel slower. They cannot travel faster. They always travel at exactly sec. A photon is emitted from a star and absorbed by your eye. From your perspective, this takes years. From the photon's perspective, it's instantaneous. Time dilation at the speed of light is infinite. Let me come back to energy. There's a deep connection between mass and energy. This is perhaps my most famous result. E equals mc squared. Energy equals mass times the speed of light squared. This equation tells you that mass is a form of energy. 1 kilogram has a rest energy of about 9 times 10 to the 16 joules. That's the energy of about 20 megatons of TNT. Now, when you accelerate an object, you add kinetic energy. The correct formula for kinetic energy in relativity is K equals mc squared minus m equals sigatom nx squared. Your total energy is your relativistic mass times squared. As your velocity approaches c, your relativistic mass approaches infinity, so your total energy approaches infinity. To actually reach the speed of light would require infinite kinetic energy. Again, impossible. Let's calculate how much energy it takes to accelerate something to high speeds. Suppose you have a spacecraft with a rest mass of 1000 kilograms. To accelerate it to 87% the speed of light, you need about 10 to the 20 joules of kinetic energy. That's about 10,000 times the total annual energy consumption of the entire human race, just to get 1 ton to 87% light speed. To get to 99.5% light speed, you need 9 times 10 to the 20 joules. The energy requirement grows without bound as you approach light speed. This is why interstellar travel is so difficult. Even with a perfect engine, you'd need enormous amounts of energy to reach relativistic speeds, and you can never quite reach light speed, no matter how much energy you have. Now let me tell you the deep reason why the speed of light is the limit. The deep reason is the structure of space-time itself. Space and time are not separate. They're woven together into a four-dimensional space-time. And space-time has a geometry, a metric that determines how distances and times are measured. Space and time are separate. There's absolute space and absolute time. An event has 4 coordinates, 3 space coordinates and 1 time coordinate. The distance between 2 events in space-time is given by a formula that mixes space and time. Squared equals c squared, squared t minus x squared minus squared minus z squared. Notice the minus signs. Time enters with the opposite sign from space. This is the geometry of space-time. And it has a maximum speed built into it. That speed is c, the speed of light. It's the conversion factor between space and time. Photons follow null world lines where the space-time interval is zero. Massive objects follow time-like world lines. They move slower than light. The speed of light is not just the speed of photons. It's the structure of space-time. It's the maximum rate at which cause and effect can propagate. To exceed it would be meaningless, like asking what's north of the North Pole. The question doesn't make sense because north is defined by the geometry of the Earth's surface. It doesn't make sense because it would violate the structure of space-time. Here's another way to think about it. Every object is always moving through space-time at the speed of light. Always. But this motion is divided between space and time. If you're at rest in space, all your motion is through time. You're moving through time at the maximum rate. If you start moving through space, you divert some of your motion from the time direction to the space direction. But your total motion through space-time remains constant at the speed of light. The faster you move through space, the slower you move through time. If you could move through space at the speed of light, you'd have zero motion left for time. You can't go faster because you can't have negative motion through time. This is why time dilation happens. When you move through space, you move through time more slowly. Your speed through space-time is constant. When you allocate more of it to space, you have less for time. This is why moving clocks run slow. And this is why nothing can go faster than light. Because the speed of light is the total speed through space-time that everything has. It's not a speed you can exceed. It's the speed you're always going divided between space and time. Massive objects must move through time, so they must move through space slower than light. Only massless particles can allocate all their motion to space, traveling at sea and experiencing no time. I want to emphasize how radical this is. In Newtonian physics, there's no speed limit. You can accelerate forever. Space is absolute. In relativity, space and time are unified. There's a maximum speed built into the structure of space-time. This maximum speed is not arbitrary. It's a consequence of the geometry of space-time itself. Particle accelerators accelerate particles to 99.99% the speed of light. The closer they get to light speed, the harder it becomes to accelerate them further, exactly as the equations predict. The energy required grows without bound. This is real. Cosmic rays provide another test. High-energy particles from space moving at 99.9999%, but they're still not at light speed. They're still moving slightly slower, and their behavior, their decay rates, all match the predictions of relativity. Time dilation is enormous for them. The numbers work out exactly as relativity predicts. The speed of light limit also preserves causality. Cause always precedes effect for all observers. If you could send information faster than light, you could send it into your own past. You could receive a reply before you sent the message. Causality would break down. The speed of light limit prevents this. It ensures that the universe makes sense, that cause and effect have a definite order. When I was young, working at the patent office, I wondered what it would be like to ride on a beam of light. This led me to special relativity. I realized the speed of light is constant, that space and time are relative, that mass and energy are related. The core insight remains: the speed of light is not just a speed, it's the structure of space-time. It's the maximum rate of causality. It's the conversion factor between space and time, and nothing with mass can reach it. Because as you approach the speed of light, your mass increases, and the energy required to accelerate you further grows without bound. These aren't separate effects. They're all manifestations of the same underlying reality, the geometry of space-time. To exceed the speed of light would require infinite energy, would violate causality. The universe doesn't allow it, not because of a rule imposed from outside, but because of the structure of reality itself. Not what intuition suggests. Tested over and over, confirmed by every experiment, the speed of light is the limit, because space-time has a maximum rate of causality, and that rate is c. Not because we haven't tried hard enough, but because the universe is structured in a way that makes it impossible. That's what I discovered. Not comfort, not simplicity. Truth.